My name is Nakangu Teddy, computer science student Chesri, Buke University. And I'm going to take you through part of our computer graphics project and the topic, visual story-based learning for accelerated refugee education using Unity and Blender. So this project focuses on using computer graphics and AI to create engaging interactive learning materials for refugee learners in Uganda. So the whole idea is to support accelerated education programs by making content more visual, story-driven, and also aligned with the new computer-based curriculum. So, with the abstract, the challenge we're trying to address here is lack of effective, engaging materials for refugee learners because the text-heavy resources that are available do not really work well, especially with language and trauma barriers. So our platform will use 3D animations, gamification, and also generative AI to create visual stories and interactive lessons. So this can also run even on low devices, low power devices, and can also be used offline. So the goal is to boost motivation and understanding, but then at the same time making it scalable for many refugee settlements. Then some of the features we're going to have are gamified stories, localized assets like avatar guidance, multilingual support, and also offline deployment. Then we expect higher engagement, also improved literacy, and enhanced digital skills from the refugee learners after they use our tool. And then with the background and introduction, first of all, Uganda is home to Africa's largest refugee population, with most children enrolled in accelerated education programs. So these programs are meant to help them catch up in school, but the challenges like lack of resources, language barriers, and also trauma make learning difficult. And on top of that, Uganda has introduced a competence-based curriculum, which requires practical, learner-centered approaches. So this creates a strong need for digital tools that are not only interactive and visual, but also adaptive to the refugee contexts. So some of the keywords we're looking at here is context-based curriculum. This is all about what the learners can do with knowledge. For example, problem solving, critical thinking, creativity, rather than memorizing facts. So it's learner-centered, it focuses on skills, and it also allows flexible, practical ways of doing things. Then another keyword we're looking is game-based learning. And this one uses game machines to motivate learners. It turns lessons into challenges or interactive stories. So it keeps learners very much engaged. Then we also have 3D animations, education. This one's to do with visualizing concepts, creating immersive experiences. Like abstract ideas are shown into motion, not just explained, like the text resources are. Then with refugee learning technologies, these tools are tailored for low resource multilingual contexts, multilingual contexts. Uh, for refugee education, then interactive education, that means it's to do with creating digital lessons with multimedia and interactivity. So that means teachers can build their own lessons using this tool. Thank you.
Benjamin, and under the literature review, we went ahead to discover which available techniques are currently on the market and what are their limitations and how can we use them to further achieve our goal. So under the asset creation, there's what we call rigging. So rigging is all about turning your 3D design models into an animatable model. So you turn your 3D design into an animation. So you first rig it to allow movement and define which parts are supposed to move. So there's what called make it animatable. This is auto rigging that uses machine learning. There's what called blender rigging. It has the manual approach and the auto approach using rigify, but its auto approach does not use machine learning but rather predefined metrics. There's also what called physics-based animation that uses deep reinforced learning to automatically animate your designs. So all these have their own limitations, and we have clearly stated how we intend to overcome this in the table. So the visualization tools come into play to further deliver the animations to the end user, to the learners. So we can use the web-based approach, which is WebGL plus Blender, or we can use Lottie. So Lottie can be used to generate lightweight animations that can run across platforms, or we can further use the Unity augmented reality, but this has a high demand on the hardware. Now the AI integration comes into play if we want to maybe achieve interactivity from the learners with the tool, or allow teachers to prompt and generate backgrounds in particular scenarios. All these have their own limitations as stated in the table, and we have a plan to overcome them as stated in the table. So also we're also able to view the available platforms that offer these services like Colibri, and if there are limitations. For example, Colibri is admin heavy and has authoring tools. So our tool can come into export competence-based curriculum lessons into Colibri ready SCORM packages, and also we have the UNICEF LP plus Watch Out Can't Wait to Learn platforms, which can be improved by enabling modular teacher co-creation, not just delivery. So that's the summary of the literature review.
Hello, my name is Namata Haula Monaisha, and starting from where my colleague stopped, the problem statement. So Uganda hosts the largest refugee population in Africa, and many of these are children who lack access to a structured, high-quality education. So the competence-based curriculum and accelerated education programs are designed majorly to bridge this gap, and the most available material is usually text-based, outdated, or linguistically mismatched. And also, in many cases, it is not available in local languages. So this means the refugee learners and other learners who have taken time out of school are left behind, which limits progress towards SDG 4, which stands for quality education, and SDG 16, that stands for strong institutions and peace. So for the technicality of the problem, the challenge majorly lies in how we deliver engaging, interactive, and culturally relevant educational content. So the focus is mainly on leveraging advanced computer graphics and generative AI to build visuals, animations, and simulations that run on low bandwidth devices. And the computational problem also lies in creating lightweight 3D models, integrating multilingual narration, and ensuring content can be accessed offline. It is an offline fast delivery. So the goal, our major goal in this is to build a computer graphics pipeline that makes education engaging even in the most resource-constrained environments. So looking at our research objective, we majorly have four research objectives. And first and foremost is we want to design and implement an offline-first content authoring framework that supports content-based, that supports the CBC, content-based curriculum delivery in refugee contexts. Then secondly, we want to develop an interactive and animated learning modules using tools such as Blender, Unity, Godot, WebXR, and then thirdly, we want to test these modules through field trials in refugee schools and measuring how they improve the learner engagement, comprehension of content, and retention. Then finally, we want to contribute to open access templates and visual learning objects that can be reused by teachers, NGOs, and content creators in Uganda and beyond Kenya and other countries as well. So by combining the educational needs with advanced computer graphics and generative AI, our work aims to create scalable, sustainable solutions that give refugee learners and other learners that have taken time out of school an opportunity to learn and succeed as others.
My name is Jonathan Mallorin, and I'm going to continue from where my colleague stopped. I'm going to take you through the methodology and architecture. So this simply means how we transform the school lessons into visual storyboards. We are using a four-layered architecture that is like building a house from the ground up. So we are going to start with content authoring. That is getting a few subjects in Uganda here, and translating them into scripts like storyboards, story-based boards like that. And then asset processing layer, that is where we now develop the 3D characters that we are going to use in the visual storyboards. We use softwares like Blender, Maya, Unity, and many others. So I think we will focus on Blender and Maya. Then the third one is the interaction engine. This is where we give the 3D characters, the objects, we give them life, we give them meaning, like we give them rules, behavior, engagement, and many others. So and then the development layer, this is where we take what we've created and then deploy it for accessibility. Then moving on, the methodological pipeline and visualization and dataset preparation simply means what we build with, like our materials. So we are going to use some simple text that is school content. So we will start with I think 4 subjects, that is the primary subjects, and then we'll move on as we go ahead. Then we'll use some quiz to be linguistic. We'll use many languages, and then we'll use some visual elements, that is the 3D objects. For example, these 2 are visual elements. Then we'll use animations, we'll use many characters. Then for the technology, we'll make sure that it is compatible for multiple devices. It runs smoothly, that is 30 frames per second or less, such that our machine language model supports multiple devices. Then this is the pipeline. So we'll start from the content, that is the curriculum, up to the deployment. Okay, deployment is here. Then we distribute, that is we analyze our product. Thank you.
We assist on 3 main grounds. That's the computational metrics, the visual fidelity, that is how similar it's the animations. The animations are to the real things, and what the users actually think about them. So under computational metrics, we'll use tools like Unity Profiler, Blender Stats, device benchmarks to test for metrics such as frames per second rendered for a given animation, the sync load times, memory usage, and the fetched inception distance. So this distance deals with assessing the quality of the generated images by, for example, GANs in AI. So visual fidelity, so the metrics under each are highlighted in the expected targets column. So visual fidelity is all about trying to mimic the actual outlook of the actual thing in the real world. So compare the two, what's generated and what's real, and try to come up with a score sheet, a score rating. So if you get 80% user rating and 85% recognitions from the user, so if users are able to recognize what this illustration, what a particular animation is actually illustrating, then that will be very good. For the user testing, we intend to carry out pre and post knowledge tests. So what did you know before you use the tool? You use the tool, now what do you know? If we get 20%, a score rate greater than 20% in learning gain, that would be very good. Then also assess the tool on the task completed by the learners. So if you get an 80% task completion efficiency using the tool, then that will, after the tool is used, then that will be very good. Then also carry out surveys. If you get a satisfaction rate of greater than 85%, then that will also be very good. So our contribution to the society, so we are going to provide a modular, interactive, competence-based lesson access to the refugees in the accelerated education program. So also going to provide a visual gamified learning for children with trauma-interrupted literacy, because this is a visual-based. It will be very easy for each learner to understand what's actually being taught without facing the barriers of language or being unable to understand what is actually being explained. Because with the visual help, it will become much easier. So we're going to empower the teachers to co-create local-based stories to further teach these students using the tool. And we're also going to allow this tool to operate on low-spec devices, further increasing the operational costs and allowing it to be accessed by very many students. It's also aligned to the SDG development goals, that's SDG 4, then the Sustainable Development Goal 16, that's peace, justice, strong, and strong institutions. So moving on to the expected impacts, where we are targeting to improve the knowledge gains by a rate greater than 20%, and also trying to achieve scalable deployment to the existing learning platforms, for example, Colibri and Learning Passport. So next steps include testing a tool on a couple of schools providing this curriculum, and also partnering with the organizations responsible for this, that's NCDC, Ministry of Education, UNICEF, and NGOs, to further use this tool and integrate this tool into the primary section of the moderated curriculum for the refugees, and also trying to implement AI-assisted content generation into the tool, further improve it. Thank you. That has been it.